Well, hello everyone. Welcome to my practice class of medical statistics. In today's class, we will talk about something about chi-square test. Today's learning goals include master the procedure of chi-square test, to be familiar the procedure of paired sample chi-square test, and understand the procedure of chi-square test for R times C table. Let's read the first example. You can read it by yourself. Okay, so maybe you have already finished reading this. In chi-square test, when some information, some numbers are given in the question, we need to list all the numbers in a special table. We call it a contingency table. And most of the time, the rows of the table can be used to represent the grouping variable. So here, in the first example, we can find that there are 200 patients in this question. And all of these patients were divided into two groups. 100 patients in group 1 took new drug, and the other 100 patients in group 2 took a current widely used drug. So they use different drugs. The first one is new, the second one is old. And the total number of patients in each group is 100. So here we can find that the types of drug can be used as the grouping variable in this question. So here we can list the numbers in the table. The first row means group. And the first group is new drug. And the second group is old drug. So let's draw the table like this. And we already know the total number in each group. 100 patients in new and 100 patients in old. And here we can list another total. That is the column total. And here in this study, there are 200 patients. And these 200 patients were divided into two groups, new and old. And next one, this table is not completed. There should be some other numbers in this table. And let's find what are the informations which are given in the question. We find that the effective rate in group 1 is 80%. So what's the meaning of effective rate? That means the ratio of the patients who are cured or who are effective in group 1 is equal to 80%. So that means the number of cured patients divided by the total number in group 1 equals to 80%. And we already know that there are 100 patients in group 1 in the new drug group. So that means how many patients are affected in group 1? Yes, that's correct. 80% times 100. So there are 80 patients who are affected after the curing, after taking the medicine. They are affected. So how about the other 20? In group 1, we have 100 patients and 80 patients are cured. And how about the other 20 patients? They are not cured, so that means they are not effective. The new drug is not effective for these 20 patients, right? Okay, so here we can use the other number, the other effective rate given in the question, 75. That is the effective rate in the old drug group. So it's similar with these two numbers. We can calculate it with the number given in the question. That is, in old group, 75 patients are cured and the other 25 patients are not cured. So we can calculate the column total in this table. For example, here 155 and 45. That means in this research, in all of the 200 patients, there are 155 patients are cured with 45 patients are not cured. So here, this is the contingency table. And we said that we most often use the grouping variable as the row and the results, for example, effect or not effect, cured or not cured, as the column variable. And don't forget, list the total in the table. So we can find that in this table, we have 4 lines. 1, 2, 3, 4. Only these 4 lines. So this is the contingency table, which is used in medical statistics. So, of course, this is the answer to the first question. Please draw the table for the question. We have already finished that. This is the contingency table. And we said that we often call this type of contingency table a four-fold table or 2 times 2 table. That means in this table there are 2 rows and 2 columns. But some of you will think that actually in this table there are 4 rows and 4 columns. Please notice that here we have 4 numbers: A, B, C, and D. If we use A, B, C, and D to represent the 4 numbers in each cell, we can calculate all of the other numbers with these 4 characters. For example, the total for group 1 is A plus B. The total for column 1 is A plus C. And here, this total is A plus B plus C plus D. So you can find that the most important number in a contingency table is A, B, C, and D. And we can find that it consists 2 rows and 2 columns. So we call it 2 times 2 table or a four-fold table. Okay, so here the second question is Perform a proper hypothesis test to compare the effective rates of the two methods and make the conclusion. And we can find that with the data of a contingency table, if we want to do the hypothesis test, we need to use chi-square test. So here, we need to use the method of chi-square test. And the chi-square test is a kind of hypothesis test. So we have mentioned that for many times in a hypothesis test, we have a general procedure. That is step 1, step 2, step 3, and the conclusion. So here, in step 1, we need to establish two decisions or two hypotheses. The first one is H0, the null hypothesis. And in chi-square test, H0 should be pi1 equals to pi2. Pi means the population effect rates. And pi1 is the population effective rates for group 1 for the new drug. And pi2 is for the current widely used drug. So this is the H0, and HA should be not equal. Pi1 is not equal to pi2. Don't forget alpha in step 1. Alpha equals to 0.05. That is the first step. And how about the second step? In the second step, we need to calculate the test statistic. And in chi-square test, the statistic should be chi-square value. And in our class, we have mentioned that for a 2 times 2 table, you can use the formula to get the chi-square value. So, do you remember what is the formula? Okay, so let's review what we have learned in our class. So here, this is the 4 most important numbers in the table A, B, C, and D. And the chi-square value equals to A times D minus B times C square times N over A plus B times A plus C times B plus D times C plus D. But please notice that there is a limit for the formula. The limit should be N is bigger than or equal to 40, and the T is bigger than 5. So the T means the expected frequency. So how can we get T? T equals to the row total times the column total over the little n. The little n is the total number of the study. So let's go back to our example. So here we can find that n, this is n, the summation of A, B, C, and D in the right corner of the table. So that is the little n. And so if we want to calculate the chi-square value, we need to calculate the expected frequency for each cell. For example, for cell A, its corresponding expected frequency should be its corresponding row total 100 times its column total 155 divided by the little n 200s. And we can find that this t is bigger than 5. Okay, so how about the other cells? You can calculate all the expected frequencies for the other 3 cells, B, C, and D. And we will find that all of these 4 cells has a more than 5 expected frequency. And we can find that n is bigger than 40. So that means we can use the formula. Okay, let's go back to the formula. Now we just put all the numbers into the formula. So here A, B, C, and D are listed in this table, and we just put all the numbers into the formula, and then we can get the chi-square value. So that is the second step. So the third step is to compare the chi-square value what we calculated with the table with the number given in the question and a critical number of chi-square value or a standard chi-square value. And we have mentioned that chi-square value follows a chi-square distribution with its degree of freedom equals to the number of rows minus 1 times the number of columns minus 1. So in a 2 times 2 table, the df is 1. So when df equals to 1, its corresponding critical chi-square value should be 3.84. In our class, we have mentioned that you need to remember this critical or this standard chi-square value. So next one, what we need to do is to compare the chi-square value, what we calculated, with this number 3.84. So if chi-square value is bigger than 3.48, that means P is less than alpha, so we need to reject H0. But if chi-square value is less than 3.84, that means P is bigger than alpha, so we cannot reject H0. So that is the step 2. And the last thing is the conclusion. So we have learned so many methods of hypothesis test, and I think you will know what is the conclusion for this question according to your results. Reject or not reject. Okay, so here, this is the answer to the first example. And this is the chi-square test for a 2 times 2 contingency table. Okay. Next one, the second example. You can read it by yourself. Okay, I think you have already finished that. Here, we can find that to evaluate 2 different methods, method A and method B, and for a special disease, 79 patients with the disease are tested by these 2 methods. That is very special. That means for each person in this 79 patients got 2 results from 2 different methods. That means for the first patients, we can use method A to test him, and we can get a result from test A. And at the same time, we use method B to test him too, and we can get another result. That is from test method B. And for each person, he will get 2 results. The first one, we will find that the results are positive or negative. So for each method, the results can be positive and negative. So there are 4 combinations for each person. And in this 79 patients, we will find that we can divide all of these patients into 4 groups according to its combination of the results from the 2 methods. So the first group is double positive. That means positive from A and positive from B. And the second group is positive for A and negative for B. And the third group is negative for A and positive for B. And the last one is double negative. Okay, so here we list all these 4 groups in a contingency table. So here, this is the contingency table. And we also use A, B, C, and D to represent these 4 most important numbers in the table. And with these 4 numbers, we can calculate all the other total numbers. Okay, so let's think about the meaning of these 4 numbers. The first one, A. That means we can find that A listed in the first row and first column. And we can find that here in this question. It's different from the first example because we don't list the grouping variable in the rows. Right? We can find that in the rows, that is the 2 levels or the 2 results of method A, and in the column is the 2 results of method B. So that is very special. Why we need to list the table in such a way? That's because for each person, he got 2 results. So that means these 2 results are from the same person. So that is paired sample. So this is the same with what we have learned in paired sample t-test. One person got 2 numbers, or 2 numbers are from the same person. So that is paired sample. So this is the contingency table for paired sample. So that is different from the 2 times 2 contingency table. But we will notice that it's still 2 rows and 2 columns. So we can still call it 2 times 2, but it's 2 times 2 paired sample contingency table. Okay. So here we have all the numbers in the table. Next one. The question is there any difference between the positive ratio of the 2 methods? So it's similar with the question in first example. So we can still use category test, and we still use the general procedure of the hypothesis test. In step 1, H0 should be pi1 equals to pi2, and the HA is pi1 is not equal to pi2, and alpha equals to 0.05. So now the point is the second step. How can we get the test statistic, namely chi-square value? In paired samples, we need to use a different formula for the chi-square value. So this formula is chi-square value equals to b minus c square over b plus c. But notice that there is still a limit for this formula. That is, b plus c must be more than or equal to 40. If we found that b plus c is less than 40, we need to correct the formula. And what is the correction formula? I think we have explained that in our statistical class, and I won't repeat it again in this practice class. You can find it in your book. Okay, so here, let's check the limit. We can find that b is 4, c is 15. So the summation of b and c is less than 40. So we need to use the corrected formula. So here, chi-square value equals to b minus c, the absolute value of the difference of b and c, minus 1 square over b plus c. So that is the corrected formula. And we just put all the numbers into the formula and we can get the chi-square value. And the other things are the same with what happened in the first example. We need to compare this chi-square value with 3.84, and then we can get the result and we can get the conclusion. Okay, so that's all for paired sample contingency table. And next one is R times C table. So when we are talking about R times C table, that means there will be more than 2 rows or more than 2 columns in a contingency table. And then we can call it R times C table. Okay, so this is the last example in today's class. You can read it by yourself. Okay, let's analyze the information given in the question. We find that all the individuals were grouped into 4 age groups, 1, 2, 3, and 4. Use chi-square test to determine whether the proportion of within or without chest pain differed in the 4 age groups. And we can find that here, with and without is similar with effect and not effect, cured and not cured. So that means 2 levels in a special variable. But we can find that here in age groups we have 4 levels because age groups are divided into 4 groups. So here, the levels of one variable is more than 2, so we can call it R times C contingency table. So here, most oftenly, we list the group in rows, but in this question it's different. We list the smallest number in the rows, and we can find that this level is 4 and this level there are 2 levels, so we list with and without in the rows. So here the first row is with and the second one is without. So this means the chest pain. We use chest pain as the row, and don't forget the total. And here we have 4 columns in each group. That is 1, 2, 3, and 4. And don't forget the total. So we need to list all the numbers into the contingency table. So here the table is constructed. This is with and this is without. We have got all of the numbers. And this is still a question about chi-square test, and we just follow the general procedure of chi-square test. But the most important thing in step 1 is H0 and HA. Don't forget that H0 in H0, we have 4 H groups. So we need to use a word. We need to use a word to represent its corresponding H0. That is, there is no significantly difference between groups. And HA is there is significantly difference between groups. And alpha is 0.05. And the second one is to calculate the chi-square value. And how can we get the chi-square value? We can use the formula what we have learned in our class. That is sigma O minus E square divided by E. And here O means the observed frequency. And here we have 1, 2, 3, 4, 5, 6, 7, 8. We have 8 cells in this table, and all of the numbers listed in these 8 cells are the numbers for O. So this is O1, this is O2, but most oftenly we say that this number is listed in the first row and first column, so we call it O11. And this one is O12 in the first row and the second column. So this one is O13 and O14, and this one is O21, O22. So that is O. And what's the meaning of E? E is actually, E is the same with T I have mentioned just now. So that means the expected frequency. And how can we get E? It's the same with T, so we can use the total row times the total column divided by the total n. This is the total n. So for each cell, you can get a E. So here, for example, let's calculate the E11. So E11 equals to 334 times 74 divided by 259. And E12 equals to 34 times 78 divided by 259. So we need to calculate each E for each cell from O11 to O24. And the next one, we need to calculate the difference between O and its corresponding E in each cell, and then square, and then divided by its corresponding E, and then calculate the summation. That means sum it up. So the summation is chi-square value. And in step 3, we need to compare the chi-square value with the critical chi-square value, or I can say to compare the chi-square value with the standard chi-square value. The chi-square value, the standard chi-square value, can be found from our textbook table A. Let's find it from table A5. We can find it from table A5. And we need the df if we want to find the critical value for chi-square. So df is number of rows minus 1 times number of columns minus 1. So in this question, we can find that it's 2 rows and 4 columns. So its corresponding df is 2 minus 1 times 4 minus 1. So it's 3. So we can use this number 3, that is df, to find the critical value in table A5. And we can find that when alpha equals to 0.05, the critical value of chi-square is 7.81. So then we can compare the chi-square value with the number of 7.81. And then we can make the decision of rejecting or not rejecting the H0, and then we can get the conclusion. So this is the procedure for the third question. This is the step 1, H0, HA, and its alpha. And this is the expected frequencies for each cell. This is the step 2, step 3, and the conclusion. And we can find that the chi-square value is 4.8. It's less than 7.81. So we cannot reject H0. So the conclusion is there is no significant difference among the 4 H groups. Okay, so that's all for today's practice class. And the next one, I will give you 3 questions as the little quiz, as the practice exercise for today's class. And I have already uploaded into the Ring Classroom. You can go into the Ring Classroom to find the 3 exercises in today's class. And you need to finish it. You can write it down in a paper and take a photo of your answer and upload it into the Ring Classroom. Okay, so that's all for today's practice class. Please finish our homework in time.